Let's take a look at section 6.4, dividing polynomials. We begin by dividing by a monomial, which is a single term. To do this, you're going to take each term in the numerator and divide it by the common denominator. So 4a squared plus 8a is divided by 2a. And so we have each term written over the 2a. We then cancel. 2 goes into itself once and into 4 twice. Canceling one of these a's with one of these leaves an extra a on top. And then over here doing the same. We end up with 2a plus 4 as our final answer. Over here we're dividing this trinomial, 3 terms, by this monomial, single term. And so once again we write each term over the common denominator. We then cancel appropriately, canceling your numbers and your letters. We end up with this as the final result. Now we're about to look at dividing by polynomials other than monomials, but before we do, we want to review the long division process because that is the process we're going to use. Recall there are basically 5 steps in long division: divide, multiply, subtract, compare, bring down. So let's say we had 784 divided by 5. You would take the 7 and divide it by 5. We get a result of 1. You then take that 1, multiply it by the 5, and write it here. You then subtract. Notice I'm following these steps here. We get 2. We then compare. The 5, the divisor, should be greater than what we ended up with here of 2, and it is. The next step is we bring down the next number, which in this case was an 8. And we begin the 5-step process all over again. 28 divided by 5 is 5. We then multiply the 5 times 5, get 25, subtract, compare this with this, bring down the next number, and begin again. 34 divided by 5 is 6. 6 times 5 is 30. Subtract, compare. There's nothing else to bring down, so this is the remainder. We are going to choose to write our remainder over our divisor, which is the 5. Remember, you can always check your answer by then multiplying the divisor times the quotient and then adding the remainder. So now let's look at dividing a polynomial by another polynomial other than a monomial. So in other words, you're dividing by something that has 2 or more terms. We're going to use long division. Now the process that we follow, we must start by making sure everything is in standard form. That means if it needs to be in descending powers, so highest power first all the way down to the constant, which has no variable attached to it. If it did, it would have been x to the 0 power, which just equals 1. So it has no variable attached. And so we make sure that every power is represented and that they are in descending powers. If anything is missing, we will put it in a placeholder by putting 0 and then whatever variable is attached. So 0x to represent whatever is missing, or 0x squared, or whatever, so on. So the division process is finished when the degree of the remainder is less than the degree of the divisor. So let's take a look at this first problem. This is the dividend and this is the divisor. So we have it written here in long division form, and we're going to follow 4 of the 5 steps we just talked about. We're going to divide, multiply, subtract, and bring down, and then repeat: divide, multiply, subtract, and bring down until we are done. When you divide, you're always going to take the first term here divided by the first term here. So 2x squared divided by x. And I have the steps written out here, step by step. So 2x squared divided by x, the x's would cancel. You'd have one more left on top, which would give you 2x. We put that on top here. The next step is multiply. When you multiply, you take what you put up here and multiply it times the entire divisor. So 2x times x plus 1. Which I distribute here, and I go ahead and transfer that over to this side. The next step is subtract. When you're subtracting, you're going to be changing the sign of each of these items. So I like to say just make them the opposite of what they were. So this was a positive 2x squared. When I say subtract it, you're then saying 2x squared minus 2x squared. So you changed it from positive to negative. So I do so in a red color to emphasize this was the change I made. This here should always cancel. All right, so then we have negative 6 minus 2x. That would give us a negative 8x. All right, so the next step is to bring down the next term, which in this case is a negative 8, and then start the 4-step process all over again. We're going to divide. Remember, when we divide, it's always just first term divided by first term. So we have negative 8x divided by x. We end up with negative 8. which I put up top here, and then I multiply this negative 8 times the entire divisor of x plus 1, and I end up with this. I write it down here, and then the next step, remember, is to subtract. And with subtracting, remember, you change the signs to the opposite of what they were in this bottom row here. So it was a negative. Well, minus a negative makes it plus. So that's why they become the opposite. All right, so this ends up being 0, and so does this. There's nothing else to bring down. So that means that this problem has no remainder. So the final answer is 2x minus 8. You can always check your answers by multiplying your quotient by the divisor, and you should end up with your dividend. Taking a look at this example, everything is in order from highest power down. Even in the divisor, you need to make sure everything is in order. So let's begin. We divide the first term, 4x to the third power, by the first term, 2x. So I have that written here. The 2 goes into the 4 twice. The x cancels, leaving 2 x's on top. So that's what we get. We put it up top here. We then take this and multiply it times the entire divisor. So 2x squared times 2x plus 4. Using the distributive property, this is what you would get, and I place it over here. I then change the signs to the opposite because I'm doing step 3 of subtract. This cancels, which it should every time. This 7x squared minus 8x squared is a negative x squared. Next step 4, bring down the next term. Step 5, begin the process over again. So we're dividing this first term by this first term here. So negative x squared divided by 2x. Well, remember, when you write negative x squared, it's like having a 1 here in front as the coefficient. We just don't usually write it in, but it's assumed to be a 1. So right now I would end up with a negative 1/2, but one of the x's would cancel, leaving a single x on top. So I end up with negative 1/2 x or negative x over 2. You can write it either way. I chose to write it negative 1/2 x. So I put that up here, and remember the next step is multiply that times the entire divisor. So negative 1/2 x times 2x plus 4. Negative 1/2 of 2 would be negative 1. X times x is x squared. Negative 1/2 times 4 would be negative 2, and then we have the x. So I take this and put it right here. Remember, the next step is subtract, so we change each sign to the opposite of what it was. This here will cancel out. This will give us a 10x, and the next step is to bring down the next term and begin the process again. So we're going to divide 10x by 2x. We end up with a 5. So we're going to put that 5 at the very top here and then multiply this 5 times the entire divisor. So when we do that, we end up with 10x plus 20, which I write here. Next step is to subtract, so I change the signs to their opposites. This was a positive, we make it negative. This was a positive, we make it negative. This cancels, so we have no remainder. Our final answer is going to be this. You can write your final answer like this or like this with the 1/2 x or the negative x over 2. Taking a look at this example, we see that we do have everything in descending power, but there is a power missing. We went from 5, we should have had then 4 before we get to the 3. So we're going to put in a placeholder of 0x to the 4th. Notice that the value of this is still 0, so we're not changing the problem, but we're putting in a placeholder. In the divisor, you have x squared. The next term you should have is x to the first power, which we do not. And so we're going to put in a placeholder of 0x for that one. Now that we have the placeholders in and everybody is in the correct order, we begin the 4-step process that we continue to repeat over and over until we are done. So to begin with, we have 3x to the 5th, which we're dividing by x squared. So first term divided by first term, we get 3x to the 3rd, and we place it here. You then take that 3x to the 3rd and you multiply it times the entire divisor. And that's what we're doing right here. Using the distributive property, this is what we would get. And so 3x to the 3rd times x squared is 3x to the 5th. 3x to the 3rd times 0x, the 3 times 0 is 0. X to the 3rd times x is x to the 4th. 3x to the third times negative 2 would be negative 6x to the third. So I write all of that here, and then step 3, we're going to be changing the signs so that we can perform the subtraction. So we change the signs to their opposites. This cancels and this cancels. Usually it's just the first term, but both of them canceled. Negative 1 and 6 would give us 5x to the third. The next step, is to bring down. Well, we bring down the next term, but remember, when we get ready to do our multiplication and so forth, we're going to end up with 3 terms underneath here that we need to subtract. We would have had that, but 2 of them canceled out. So we're going to go ahead and bring down another term. All right, so let's begin the division process again. 5x to the third divided by the first term, x squared. We get 5x. We put that up here. 5x now times the divisor. We end up with this, which we wrote down here. We then change all of the signs to their opposites, as I have in red, and do the subtraction. This cancels. This gives us a 4x to the second. Negative 12 plus 10 is negative 2x. And the next step, 8, is to bring down the negative 8. We then begin the process again, dividing 4x squared by x squared. We end up with 4. We put that up top here. We then multiply the 4 times the divisor. We end up with this, which I wrote here. Change the signs. This was positive, make it negative. This was negative, make it positive. Subtract, this cancels. Negative 2 minus 0 is still negative 2x. This is 0. We have nothing else to bring down after we've done our subtraction, so this is the remainder. We write the remainder minus, because it was a negative number here. If this had been a positive number, I would have put a plus sign. And you want to put the plus or minus sign right here, not in the numerator. It needs to be separate from the 4. All right, so that plus or minus sign will separate this from the remainder. So we have a negative 2x over the divisor. Notice I did not include the 0x in the divisor because it's not needed. The purpose of the 0x and the 0x squared was to put in a placeholder for us so that you notice throughout the process our like terms all line up as they should. All right, what we're going to show you now is another form of division called synthetic division. However, it only works if you are dividing by a binomial of the form x minus c. So in this last example, we weren't dividing by x minus c, but rather x squared minus 2. We could not use synthetic division there. This example, 2x plus 4, is not in the correct format because notice the coefficient of the x here is 2, but the coefficient of the x for synthetic division is a 1. So we need the binomial to be in this form in order to do the division. So when it's written in this format, one of the things we need to do is very similar to the other process of long division, make sure everything is in descending powers, and also make sure if there's anything missing that you put in a placeholder. Then you want to identify what c is. Remember, this is written in terms of subtraction. So x minus 3 would mean c is equal to 3. We have our x, we have our subtraction sign, c is equal to 3. Here c is equal to 5. Here it needs to be written in terms of subtraction for me to identify c, so consider x plus 2 could be written as x minus negative 2, right? Because the double negatives would become a positive. If that's the case, then now I have it in the correct form and I can say c is negative 2, and here c would be negative 7. So what would be an easy way for you to identify c? Probably just to say you're looking for the opposite or taking the opposite value of what you see. So this would be positive 3, this would be positive 5, negative 2, negative 7.